bit about other things you can do. So far, we've talked about textures as essentially coloring surfaces, but there's a sort of wider range of thinking about textures. The first would be to say, forget it. We're not going to have 2D textures that we sort of paste onto our surface. We're going to define some function which defines a texture in 3D. And then for every 3D point, instead of having to have a UV mapping, we just have a direct mapping of XYZ. This is what the texture is at this point. So these are often done procedurally. So this is an example of a procedural texture. So somebody wrote a piece of code which has some random values and sine waves and other things in it. And for each position on this pot, they just look up. They just use that code to look up what the texture should be, rather than actually storing an image, which is a map. You could also store a 3D image as a map, would be another way to go. So solid texturing is something that exists. Bump mapping is another thing that we can do with textures. Remember, texture is just a chunk of 2D data, right? It's just a 2D array stored on the graphics card. We can do other things. We happen to have been setting it to the color, but we could set it to another value. So what does bump mapping does? It says, interpret the thing stored in my array as a height field, and we're going to use it to change the normals. So we haven't talked much about normals because they usually come up in lighting, but for a real bump, the geometry shape, the orientation of the surface is changing according to these normals. So we could put a fake bump. Suppose we just had a big flat triangle here. We could nevertheless change the orientations when we do our rendering. This will come up in lighting. But when you calculate lighting, the normal is a key component of doing lighting. So if we just go fake it and set these normals, rather than setting them all to be straight, we can make things look like they're more bumpy. So here's a green teapot. No geometry has changed in this teapot. We haven't added any triangles to try to get all this detail. All we've done is mess around with the normals during the rendering by looking up out of some kind of bump map. So this is a way to get additional details, just like color details, but now we got a different kind of details. So let's look at an example with color. So this is just a texture with the color pasted on. And this is the texture with an additional bump map in addition to the color pasted on. And many people believe this looks more real. So therefore they use bump maps. So this data is not storing color, it's storing height. Now, instead of storing height, we could just store those normals directly, right? We use those normals to calculate height. So let me talk about this corner first, since it's flashing around and getting in everybody's face. So here's some real geometry. We have a cone and a sphere and some things that have real geometry. Now, if we try to fake the normals, there's no real geometry. So you see how the cone sticks out of the top up here? Well, this cone is not sticking out of the top because it's really a flat piece of geometry. But we are faking what the lighting is doing, right, in some kind of way on this. So this is an example that's not really getting the effect that you wanted to get because it's not real, right? So this could be bump or normal mapping. In this particular example, it was normal mapping. Okay, so that's what you're seeing down here in this flashing picture. So let's go back. Let me start with what you can get out of this. This could be bump or normal mapping. In this case, it's normal mapping. This is the normals stored in a texture map. Here's a high resolution version of the mesh. Here's a low resolution version of the mesh. And this is the low resolution mesh, this exact same triangles and geometry with many fewer polygons than this one, but using the information in the normal map to get back something that looks approximately like the high resolution mesh. So it's a way to add detail, just like bump maps. So what's the difference? Rather than storing a height field in my image, I'm going to store the actual normal directions. The normal vector will have an XYZ component. If we visualize those XYZ components just as red, green, blue instead, then it might look like this. So I store an image that looks like this, and the red, green, blue are storing the normal map XYZ. So here's another example with this normal map applied onto here. So bump map versus normal map, which one should you use? They're achieving a very similar kind of effect. I've glossed over some details of exactly which coordinate space these normal maps are stored in. But I think the general idea that you're storing normals that you're going to apply on here is reasonably straightforward. So what if we wanted to get real geometry, right? So here's our color texture map. What if we wanted our object really had bumps in it, right? So here's our height field if we had a bump map, but we don't want to just use it. We really want to just change our geometry. You could do this. This is also possible. So this is called a displacement map. So here's the same rendering, but with a displacement map on the rocks now. And you can see there's actual shape. Now, this is not just a coloring change. So to get this, we don't just change the color in the fragment shader and mess around with the calculations there. We have to go in the vertex shader, look up in the texture map in the vertex shader, and when we get a coordinate, rather than just multiplying times the model matrix, which you've done so far, we're actually going to do some other math to change around that coordinate. So we passed in the position XYZ, but according to the displacement map, it should move, and we're going to let the shader actually go do some changes to where the geometry is at. So this is something that would happen in the vertex shader. And you can get effects like this. Just to compare bump mapping and displacement mapping, here's a source texture. When we do bump mapping, we still have a perfect sphere, right? We haven't changed the sphere. All we've changed is the lighting. So we can get the effect, the look of there's bumps on this thing because we've changed around the lighting, but we haven't actually changed the shape. In displacement mapping, you can see along the silhouette edge, the actual shape of this thing has changed. But the computation is higher, right? I need to be able to actually move around the vertices in order to do it. So I could do this with large triangles. This I would need small triangles in order to do it. Environment mapping is another thing we could do with textures. Rather than applying the color directly onto the object at some UV position, if we knew where our camera was and we knew the normal of the object, we could go calculate a reflected ray. We'll talk about this more when we talk about lighting. But you can imagine there's some known vector here. And if we knew some information about the pixel we're calculating, we can calculate this reflected vector. And then we could find out where it hits a box surrounding our world, right? If we were using a cube map, it would be a box. We find out this point, and we look up the texture at that point, rather than looking at the texture at here. So if this object rotated, these rays would go off in other directions and land on our environment map. These are examples of environment maps. So this is stored in a cube map. WebGL likes to use these. This is in a cylindrical environment map. This is in a spherical environment map. They're just different ways. You would just change your lookup coordinates, right? This is some position in space. You just need to map it to whatever is your mapping for how you've stored your environment. So on the outside here, we see the environment map rendered on this outside cube. And then here, this object has been made to look chromish by calculating these reflected rays and looking up the environment map color and pasting it into those pixels when it comes there. So another thing we can do with textures. So the last thing I want to mention about textures is a really lame hack, but you've probably seen it in lots of games that you've played. So I thought it was worth mentioning. So textures are for adding detail. So this is color, but from some camera position, we would still have to have some complicated geometry. Imagine like a tree. I need all those leaves, or I need to know how is it shaped. So a common trick that's played is to just put a big square there, stick our clouds or our trees onto this texture, and then as we move our camera around in the world, we're just going to keep rotating these squares so they're always pointing towards us, right? You can never get on the side and look at it because we just keep rotating the square. So particularly in, say, racing games and these kinds of things, it's very common for trees and building fronts to be done in this kind of way. So another thing. So textures are just pieces of information that we can use when we're calculating color in our renderers in whichever way you might want to use a 2D array to store information.